Hello everyone. In this session of CCNA series, I will discuss OSPF network types. One of the key concept in OSPF is the network type. The network type determines how OSPF will route data packets across the network and permit you to configure OSPF over a variety of different underlying network technologies. As a network engineer, working with OSPF, you must understand the differences between each OSPF network type and their compatibility. OSPF supports several different network types based on the physical link types. And some of the common network types that are defined by OSPF are broadcast network, point-to-point network, non-broadcast network, point-to-multipoint network, point-to-multipoint non-broadcast, and loopback. Only the first two OSPF network type, that is broadcast and point-to-point, is included in the CCNA exam topic. So let's go ahead and discuss about these two network types. The broadcast network type is the default network type for an OSPF enabled Ethernet interface. The OSPF broadcast network type is used on network with multiple OSPF routers connected to a single shared broadcast medium, such as Ethernet LAN. They are used when all the routers in a network need to be able to communicate with each other. In broadcast network, OSPF router need to elect DR and BDR to reduce control traffic, improve efficiency, and minimize routing update. So we will try to understand more about this broadcast network with a topology which I have configured in GNS, and I will log into those devices and use some show commands to show how it displays the network type, which one is DR and which one is BDR, and how we can influence the DR BDR election. So for broadcast network, I have created a small topology where I have a shared Ethernet segment, that is switch. These four routers are connected to this switch, and they have a subnet of 192.168.1.0/24 with .1 on R1, .2 on R2, .3 on R3, and .4 on R4, with router IDs configured as 1.1.1.1 on R1, and then similarly 2.2.2.2 on R2, 3.3.3 on R3, and 4.4.4 on R4. So let me log into this device and show you. Here I have show as neighbor. Okay, already have a neighbor configured, as you can see, with R2, R3, and R4. R1 is showing that. So show IP OSPF neighbor command, it displays detailed information. Okay, the interface through which the device is connected to the neighbor, you can see. Then what else do we have? The IP address of the port on which the device is connected to the neighbor. As I said, it also shows the IP address through which your neighbor is connected. Okay, and also OSPF priority of the neighbor. By default, currently all the neighbors, priority is 1. Actually, the priority, let me try to explain you. For multi-access network, the priority is used during the election of DR and BDR. Suppose if you have a tie, then the priority comes into the picture, or it can influence the OSPF DR BDR election as well. Okay, so as I said earlier, you can see here R4 is acting as a DR, and R3, that is 3.3.3, is acting as a BDR. So all discovered routers on this link should become neighbors and at least reach the two-way state. For all the neighbor relationships that include DR BDR, the neighbor relationship should further reach the full state. So on all the routers, whichever neighbor is DR or BDR will be in full state. Let me show you on R2 as well. Here you can see R3 and R4 is DR BDR again. Similarly on R3 as well, but on R3 it will not show BDR, but it will show DR other. So in this setup, R1 and R2 are acting as a DR others. Okay, if I go on to the R1 again, here you can see R2 is R1 is DR acting as a DR other with R2. So another command that is very helpful is show IP OSPF interface brief command. Okay, so in this output you can see I have 2 out of 3. 2 out of 3 neighbors are in full state. Okay, uh, what else do we have here? You can also see, I think, the cost, the IP address of this interface and all. But the important thing is in which state you are, and how many neighbors you have in full state, and how many total neighbors you have. Okay, there is another important command which shows the OSPF network type. Okay, that command is show IP OSPF interface. Okay, if you type in the command our interface FA0/0, which is connected to, let me show you, FA0/ connected to the switch, and if you see here the network type is broadcast. This confirms that our network type is broadcast. It also lists like a lot of other options, like the state, priority, and then cost, router ID, and a lot of things. Okay, so let's try to influence the DR BDR election. Like in some cases, you may want to influence it. You can influence it by either configuring the highest router ID or changing the OSPF priority as the highest priority, because highest priority will always win, but it will not preempt the existing DR BDR until the OSPF process is cleared. So let me change the OSPF priority to 99 on R1. For that I have to hop onto the interface to which it is connected, 0/0. Let me confirm, yes, and then type in IP OSPF priority 99, and then I need to clear the OSPF on DR BDR as well. Okay, so I have changed and cleared all the OSPF process. Let us wait till the OSPF neighbor is up. Let me hop onto the router R2 and see. Need to clear the OSPF process. As you can see, 1.1.1, that is R1, has become DR. After changing the priority, R1 has become the DR. So let's go back and look at another network type, that is point-to-point network type. OSPF point-to-point network type is used on network with two OSPF routers connected by a single point-to-point link. Here there is no DR-BDR election. Using network type of point-to-point tells the router to not use a DR-BDR on the link. Let me hop on to the router R5 and R6, which is connected via a single link and which includes subnet 192.168.2.0 with router ID as 5.5.5 for R5 and router ID 6.6.6.6 for R6. So if I hop onto this device and do show IP OSPF neighbor, right? This command will list a neighbor, that is router R6 with router ID 6.6.6, and it is fully adjacent neighbor. And surprisingly, if you see here, there is no DR-BDR. It is just a dash. This acts as a reminder that the link does not include a DR or BDR. Correct? Now let me type another command, show IP OSPF interface brief. This will also show the state of the link, that is point to point, and the neighbors 1 out of 1 is in full state. So when using Ethernet WAN link that behave as a point to point link, consider using OSPF network type point to point rather than using default broadcast type. If you want to see the show IP OSPF interface command here, you can see the network type is point to point. Next, let's discuss about the issues that can prevent OSPF neighbor adjacencies. Here I have a topology where I have 5 routers. Okay, one of the issues that can occur is misconfiguration of areas on the same LAN. For example, I have 2 areas configured on the same LAN with R1, R2, R3, R4 with its interfaces configured under area 0, and interface of R5 is configured under area 1. This will prevent the OSPF neighbor adjacency. Another issue that can prevent OSPF neighbor adjacency is duplicate router IDs. On each router you have a router ID. If you see on the router R2, instead of configuring 2.2.2, by mistakenly if you configure 1.1.1.1, that will also prevent OSPF neighbor relationship as well. Another important timer you need to make sure is matching is hello and dead timer. If you have a mismatch hello and dead timer values, then it can prevent OSPF neighbor adjacencies as well. And in case if you have shut down the OSPF process on any router, it will never become a neighbor. Also, there are some issues that would allow adjacencies but prevent IP routes. Like in OSPF, there are some issues to discuss, like in which show IP OSPF neighbor command does lists a neighbor, but due to some other problem, it prevents the addition of OSPF route into the routing table. And these two main issues are a mismatch MTU setting. If you have a different MTU configured, then it can cause a problem. Or a mismatch OSPF network type. The two OSPF router can become OSPF neighbor as shown in the output of the show OSPF neighbor command and reach a two-way state. Even if they happen to use different MTU setting on the interface, they will fail to exchange their LSDBs, correct? And after trying and failing to exchange the LSDBs, the neighbor relationship also fails. So the second issue, which is mismatch OSPF network type. Interestingly, if you misconfigure network type such that one router uses broadcast, another uses point to point, the two routers become fully adjacent neighbors. They exchange their LSDBs, but they will not add IP routes to their routing table. That's it for this session. I hope this was informative for you. Thank you.